You are standing on a limestone ridge in southeastern Turkey. It is roughly 11,600 years ago. There is no metal anywhere on Earth, no wheels, no written language, no domesticated animals strong enough to pull a load. The people around you have no pottery, no permanent houses, and no agriculture. They are hunter-gatherers. And they are building a cathedral, not out of wood, not out of mud, out of stone. Pillars of carved limestone, some standing over 5 meters tall and weighing as much as 16 tons, cut from the bedrock beneath your feet, dragged to prepared foundations, and raised upright into precise circular formations. Each pillar is carved with intricate reliefs of animals: foxes, vultures, scorpions, wild boar, snakes. Some of them have arms and hands carved in low relief along their sides, as though the pillars themselves are standing human figures. You do not know what these figures mean. Nobody alive today knows for certain. But you understand, immediately, that whoever carved them moved stone at a scale that should not have been possible for people who had not yet figured out how to grow wheat. This is Gobekli Tepe. And the question it asks, the same question asked by Stonehenge, the Great Pyramid, the moai of Easter Island, and the walls of Sacsayhuaman, is the question that has haunted every person who has ever stood in front of a megalith and looked up. How? Now hold that image, and go somewhere else. Not 11,000 years into the past, tonight, on the island of Sumba, in eastern Indonesia, a community is braiding rope, sharpening wooden stakes. A water buffalo is being led out for a feast that has not started yet. Tomorrow, without a single machine, they are going to quarry a stone, drag it across the landscape, and raise it over a tomb. This is not a reenactment. It is not a documentary crew paying villagers to perform the past. It is Tuesday. Keep it in your head, because by the end of this video, it is going to answer a question that has nothing to do with physics. Here is the real question, and it is not how. In 1722, a Dutch admiral named Jacob Roggeveen became the first European to set foot on Easter Island. He saw the moai, the massive stone heads, some over 10 meters tall, and he asked the Rapa Nui people standing next to him the obvious question. How did you move these? They told him. Clearly, specifically, in their own language, passed down through generations. For the next 290 years, almost nobody believed them. European visitors wrote the answer down as folklore, as myth, as a charming story a colonized people told, instead of admitting the real technique had been lost. The Rapa Nui said the statues walked, nobody listened. That single fact, not the stone, not the rope, not the 20-ton weight, is the actual mystery inside every megalith on Earth. It is not a mystery of engineering, it is a mystery of listening. Every technique used to quarry, move, and raise these structures has been demonstrated by modern experiment, more than once, with tools available to any Neolithic community. The knowledge was rarely lost. In several cases, it was standing right in front of us, and we called it a story. Start with the one nobody has solved yet, because honesty matters more than a clean narrative. In the stone quarry at Baalbek, in modern-day Lebanon, sits a block of limestone that was never moved anywhere. In 2014, a team from the German Archaeological Institute measured it and estimated its weight at roughly 1,650 tons, about the mass of 275 adult elephants, still attached to the bedrock it was cut from. Whoever quarried it walked away and left it there, presumably because even they could not figure out how to move something that heavy. 60 meters away stand the trilithon stones of the Roman temple complex, each weighing around 800 tons, moved and placed with total precision. So the quarriers clearly knew how to move enormous stones. They just could not move this one. Nobody today knows exactly why. Keep that in mind for the end of this video, because the honest answer is going to be, we don't know. And that answer is going to matter more than it sounds like it should. The word megalith comes from the Greek megas, meaning great, and lithos, meaning stone. Any structure built from stones weighing more than a ton qualifies, and that definition covers an enormous range. The blue stones at Stonehenge weigh 2 to 5 tons each. The sarsen stones in the outer circle average around 25 tons. Megaliths exist on every inhabited continent, spanning more than 10,000 years, built by cultures that never made contact with one another. Bread was invented independently on multiple continents. Agriculture arose separately in at least 7 regions. Megalithic building followed the same pattern, not because one civilization taught the rest of the world, but because gravity does not care what language you speak, and a lever works the same way in Peru as it does in Wales. The physics converges because physics is universal. What does not converge, it turns out, is who gets believed when they try to explain it. Before you can raise a megalith, you have to get it out of the ground, and this is where most people assume you need advanced technology. You do not. You need water, wood, and patience. At Craig Rosie-Feline in Wales, archaeologist Mike Parker Pearson identified the source quarry for some of Stonehenge's rhyolite bluestones. The rock there fractures naturally into vertical pillars along existing geological joints. Prehistoric quarry workers drove wooden wedges into those cracks. When water reached the wood from rain or poured on deliberately, it swelled, and the expansion force was enormous, enough to split multi-ton blocks cleanly from the bedrock. Stone wedges found in place at the site confirmed the technique. No metal, no fire, just wood, water, and an understanding of how rock breaks. In Egypt, the stone demanded a different method. At the granite quarries of ancient Syene, modern-day Aswan, workers used dolerite pounders, fist-sized balls of extremely hard igneous rock, to bash a channel into the granite around the block they wanted. The unfinished obelisk, still lying in the Aswan quarry, commissioned under Pharaoh Hatshepsut around 1460 BC, shows exactly how this worked. It would have stood roughly 42 meters tall and weighed an estimated 1,100 to 1,200 tons, making it the largest obelisk ever attempted, until a crack appeared during quarrying and the project was abandoned. The trench marks are still visible. Thousands of dolerite balls, swung by thousands of hands, pounding a channel into solid granite, inch by inch, for months. Neither method needed metal that could outcut stone. Copper tools existed in both regions by this period, but copper is too soft to carve granite or split limestone efficiently. It was used for finishing work, not the heavy quarrying itself. The heavy lifting, literally, was done by exploiting a weakness that was already there. A joint in the rock, a vein, a natural fracture line. Quarrying megaliths was never really about brute force against solid stone. It was about finding where the stone already wanted to break, and giving it a reason to. There is nothing mysterious in either method. It is unbelievably tedious. Tedium, applied by organized groups over stretches of time we find almost impossible to imagine, is the actual answer to how megaliths began. Once a stone is quarried, it has to move, and this is where imagination tends to run wild. How do you move a 25-ton block without a wheel? You drag it, on a sledge, over wet ground. It is easier than it sounds. In 2014, physicist Daniel Bohn, at the University of Amsterdam, settled a question Egyptologists had argued over for decades. A tomb painting from around 1900 BC, showing the transport of a colossal statue of the provincial governor, Jehutihotep, depicts 172 men hauling the statue on a wooden sledge, and, standing in front of it, one person pouring water onto the sand. For years, people assumed this was ceremonial. Bohn proved it was engineering. Wetting desert sand to roughly 2 to 5% moisture creates capillary bridges between the grains, doubling the sand's stiffness and cutting friction by as much as half. That one person with a water jug was not performing a ritual. He was cutting the labor force in half. The bluestones at Stonehenge traveled roughly 250 kilometers from the Preseli Hills in Wales to Salisbury Plain, most likely on timber-railed sledges greased with animal fat or water, pulled by teams small enough that the logistics are almost boring. The heavier sarsens came from much closer. For decades, the assumption was somewhere on Marlborough Downs. In 2020, geologists at the University of Brighton traced the chemical signature of the stones more precisely to a site called West Woods, about 25 kilometers north of Stonehenge. A small correction, but a reminder that even the basic facts of this monument are still being updated. Same physics, either way. More rope, more hands. Now go back to Easter Island, because this is where the story most people get wrong finally gets corrected. For most of the 20th century, the standard theory was that the moai were dragged flat on log rollers, a theory that conveniently also explained the island's deforestation. In Sacsayhuaman, anthropologists Carl Lipo and Terry Hunt proposed something the Rapa Nui had been saying since 1722. The statues were not dragged, they were walked. The moai's forward-leaning center of mass and D-shaped base make it naturally inclined to rock side to side if you pull it correctly. Lipo and Hunt built a 4.35-ton replica, gave 18 people 3 ropes, and walked it across a field in a controlled zigzag, left, right, the exact motion described in Rapa Nui oral tradition for nearly 300 years. The islanders were not telling a myth to cover for lost knowledge. They were giving a precise technical description, in the only language available to explain it, to people who had already decided a Polynesian community could not have solved a problem this elegant. It took until 2011 for an experiment to catch up to what had been said out loud since 1722. 289 years. That is not a gap in engineering. That is a gap in who we were willing to believe. Quarrying and transport get most of the attention, but raising a stone upright, without a crane, looks the most impossible to modern eyes. At Stonehenge, archaeologists have found angled stone holes, pits dug specifically to receive the base of an upright. One side slopes gradually, the other is steep, often lined with wooden stakes. Workers dragged the stone to the pit's edge, tipped it over the lip, and let it slide down the ramp until the base dropped into the hole. From that angled position, teams used A-frame timber shear legs, ropes, and raw effort to haul the stone upright, with the steep back wall of the pit acting as a brace. Once vertical, the pit was packed with rubble to hold it in place. Engineers who have modeled this sequence estimate that raising a 25-ton sarsen this way needed somewhere between 100 and 200 people pulling in coordination. A large crew, but not an impossible one, and well within the population Neolithic Britain could gather for a single event. The hardest part of the job was never the pulling. It was keeping 200 people pulling in rhythm at the same moment, without a shared language of command. That is a coordination problem, not an engineering one, and it shows up again and again in every megalith on this list. Wally Wallington, a retired construction worker from Flint, Michigan, spent years proving this, at a scale that should embarrass anyone who reaches for aliens as an explanation. Using nothing but wooden levers, small stones as pivot points, and counterweights, he moved and raised concrete blocks weighing up to 20 tons, alone. Place a pivot stone near the block's center of mass. Use a long lever to tilt it slightly. Slide a thin shim underneath. Repeat, hundreds of times, walking the block across the ground 1 degree at a time. It is not fast. It is not glamorous. It works, using materials available to any Neolithic community on Earth. One retired American, working by himself, raised a 20-ton block with wood and patience. 100 coordinated people, with the same tools, could raise something 10 times heavier. The engineering does not change. More mass just means more hands. And then there is the structure that makes every other megalith look like a warm-up exercise. The Great Pyramid of Giza, built for Pharaoh Khufu around 2560 BC, an estimated 2.3 million stone blocks, an original height of 146.5 meters, a total mass of roughly 6 million tons, built in approximately 20 years. That works out to roughly 315 blocks quarried, transported, and placed per day, every day, for 2 decades. For centuries, the assumption was that this required an army of slaves. Herodotus claimed 100,000 men. He was wrong on both counts. Egyptologist Mark Lehner and archaeologist Zahi Hawass excavated the workers' village at Hayt el Ghurab, near the Pyramid Plateau, and found something that did not look like a slave camp. It looked like a company town, bakeries turning out hundreds of loaves a day, breweries, cattle slaughterhouses providing quality beef, medical facilities where broken bones had been set and healed. Workers were organized into crews of about 20, with competitive names painted in red ochre directly on the blocks. Friends of Khufu, drunkards of Menkaure. These were seasonal laborers, most likely conscripted from farming communities during the Nile flood season, when agricultural work was impossible anyway. Lehner estimates the permanent workforce at 20,000 to 25,000 people at peak construction. Large, but about the size of the crowd at a modest football stadium, not an empire's worth of chained bodies. In Hanin Kongtamwitam, a joint team from the French Institute for Oriental Archaeology and the University of Liverpool found a well-preserved ramp system at the Hatnub Alabaster Quarry, dated to roughly Khufu's era. A steep incline, flanked by staircases with post holes on either side, holding wooden beams that created a pulley-like system for hauling blocks upgrades previously thought impossible for the period. The Great Pyramid is not evidence of lost technology. It is evidence of management, feeding 20,000 people, coordinating their labor, maintaining quality control across 2.3 million blocks for 2 decades, so effectively that the result has survived for over 4,500 years. One more piece remains genuinely open. In 2007, French architect Jean-Pierre Houdin proposed that the pyramid's lower third was built with a straight external ramp, and the upper 2/3 with an internal spiral ramp threaded just beneath the outer casing, workers hauling blocks up through a hidden corridor and emerging at each corner to set them in place. The theory is unproven. A later microgravity scan did detect an internal void in roughly the position Houdin predicted. Intriguing, and not remotely conclusive. File it under promising not settled, which is the honest category most of archaeology actually lives in. Sheer mass is only half the story. The other half is precision, and some of the most exact stonework in human history was achieved without a single metal tool. At Sacsayhuaman, overlooking Cusco in Peru, the Inca built walls from polygonal boulders weighing up to 120 tons, fitted so tightly you cannot slide a blade between the joints. No mortar, gravity and geometry alone. For decades, this was cited as evidence of lost technology, until archaeologist Jean-Pierre Protzen of UC Berkeley sat down with a pile of river cobbles and a block of andesite and simply tried it. He succeeded. Inca masons pounded and pecked the stone surfaces with hard quartzite hammerstones, repeatedly test-fitting blocks, marking high spots, and pounding them down until the surfaces mated perfectly. No lasers, no power tools. Just rhythmic pounding, trial and error, and a willingness to spend days perfecting a single joint. At Newgrange in Ireland, built around 3200 BC, 6 centuries before the Great Pyramid, the precision is astronomical, literally. A narrow opening above the entrance, the roof box, is positioned so that at sunrise on the winter solstice, a beam of light enters the passage and illuminates the inner chamber for roughly 17 minutes. It still works, after 5,200 years. None of this happened in one place and spread outward. It happened independently, over and over, in cultures with no contact with each other, because the physics converges even when the people don't. In Korea, roughly 40,000 dolmens, more than anywhere else on Earth, stand in fields that are still farmed around them, some capped with a single slab the size of a delivery truck. At Carnac in Brittany, France, more than 3,000 standing stones run in parallel rows for over 3 kilometers, raised between roughly 4,800 and 2000 BC, gray granite shoulders breaking out of green pasture, cattle grazing between rows that have not moved in 6,000 years. Nobody agrees on why the rows run where they do, and for the purposes of this video, nobody needs to. The point is not the meaning. The point is that a culture with no written records, on the opposite end of the continent from Nabta Playa, arrived at the same solution: cut it, drag it, stand it up, without a single shared conversation. At Nabta Playa in southern Egypt, nomadic cattle herders aligned a stone circle to the summer solstice around 4800 BC, more than 2,000 years before Stonehenge, in a desert where nothing has grown for millennia. At Dantija on Malta, builders raised limestone blocks up to 20 tons around 3600 BC, and carved stone spheres found scattered near the site suggest they experimented with something like ball bearings to roll the weight into place. Along the border of the Gambia and Senegal, more than 1,000 laterite pillar circles, reddish stone against green floodplain, were raised between the 3rd century BC and the 16th century AD, a UNESCO World Heritage Site most people have never heard of, built by people who left no name behind, only the stones. Now come back to Sumba, to the community braiding rope from the beginning of this video. On the island of Sumba in eastern Indonesia, communities still quarry, transport, and erect stone tombs weighing 10 to 30 tons, using nothing but rope, wooden sledges, log rollers, and human muscle. The process is not hidden. It is public. It is festive. Hundreds of people haul the stone on log sledges, chanting in unison to keep their timing. A water buffalo is sacrificed. A feast is held for everyone who came to pull the rope. The megalith is not just a structure, it is a social event, and the act of building it binds the community together the same way it always has. There is evidence this same dynamic drove construction thousands of years ago, not just on Sumba. At Durrington Walls, the Neolithic settlement near Stonehenge, dating to roughly 2500 BC, excavations recovered tens of thousands of animal bones, mostly pigs. Isotopic analysis showed these pigs were brought from all over Britain. People traveled hundreds of kilometers, livestock in tow, to attend enormous communal feasts. The feasting was the incentive that gathered the labor force. You came for the meal. You stayed to move the stones. The oldest known construction project in British history was organized the same way a barn raising was organized 200 years ago in rural America, except the barn weighed a few thousand tons, and the reward for showing up was a party that lasted for days. Tomorrow on Sumba, they will do it. And they will do it exactly the way their ancestors did, the same way the builders at Gobekli Tepe did it, 11,600 years ago. So here is what we actually know, and what we do not. We know how megaliths were quarried: wooden wedges swelled with water, dolerite pounders, patient fracturing of stone along its natural weaknesses. We know how they were moved: wet sand, timber sledges, rope, rhythm, and enough hands. We know how they were raised: angled pits, levers, counterweights, ramps, and time. Every one of those techniques has been independently demonstrated by modern experiment. Wallington moved 20-ton blocks alone with wood. Lipo and Hunt walked a moai with 18 people and 3 ropes. Bond proved wet sand cuts friction in half. None of it required a lost civilization, and almost none of it required believing anyone we didn't already believe. Z. What we do not know, honestly, is how a small number of specific sites were handled, including that 1,650-ton block still sitting in the quarry at Baalbek. We don't know, and that gap is not a hole for aliens to fill. It is an honest admission that the archaeological record, like most records, is incomplete. Tonight, on Sumba, they are still braiding the rope. Tomorrow, they will move the stone. If you want to know how a megalith gets built, that is still the answer. It has always been muscle, rope, wood, and a community willing to listen to the people who tell you it can be done, including, it turns out, the ones who told you 300 years ago.